should be easier for you. So up at the top, we essentially have a times the nth root of b, this is just a generic format, times x times the nth root of y. First of all, in order to multiply radicals, they do have to be a common radical. Either you're taking the square root of both or the cubed root of both. Unfortunately, you won't be able to combine them. You just won't be able to do the multiplication at all if one's a square root and one's a cubed root. Can't do it. But for now, as long as it's the same root, the nth root on both of these, the a times x gets multiplied as your new coefficient, and then it remains the nth root of by. So what's in front of the radicals gets multiplied, what's under the radical gets multiplied. And then, so I would say multiply first and then simplify. You could simplify first, then you can multiply them, but you'll run the risk of then having to simplify a second time. So I just say wait until the end to do the simplifying, whereas with adding radicals, you definitely have to simplify first and then add. So on this first one, root 10x times root 8x is just going to be root 80x squared. And then we're going to simplify. Alyssa, tell me a perfect square that goes into 80. Did I say Alyssa? No, I said Alexa, right? Oh, I meant Alexa. Sorry. 16 goes in how many times? 5. And actually, that is definitely the biggest one. So root 16, root 5. What do you think about the root x squared, Owen? Good. So I really don't need to touch it at first, but then go ahead, Owen, tell me what my final answer is going to be here. Yes, but usually anything that's like a whole number we're going to pull out in front. So I wouldn't leave that x at the end. I would bring it to the front. 4x root 5. Does that make sense, Owen? Good. Okay, on number 2, they're both cubed roots. So take a stab at this, Eric. So 10 cubed root 72. Keep going with me, Eric. How can we break down 72? Name a cubed root, or a perfect cube, rather. 8. Does 8 go in? Okay. It might not be the biggest one, but at least we found one. And if it's not the biggest one, we know that we can handle that later. So, Eric, what would you break 72 down into? 8 times 9. So, the cubed root of 8 becomes 2. 10 times 2 is 20. Cubed root of 9. Now, Eric, do any perfect cubes go into 9 evenly? 3 is not a perfect cube. You're getting confused probably with 50% of the other people in here because you know instinctually that the square root of 9 is 3. And because you are most used to square roots, your mind just takes you there. It's not the square root, though. It's the cubed root. So your perfect cubes are 8. 8 doesn't go into 9 evenly. 27, and you're done, right? Because that's already bigger than 9. 27 obviously doesn't go into 9 evenly. So this is it. So he did actually pick the biggest perfect cube. It was the only perfect cube, and that's your final answer. Now, the next one is a little bit maybe tricky for some of you, but I want Jack Taylor to take a stab at it. What would you guess this is, Jack? Nope, I can actually multiply these. What makes you think I can't? I don't see a radical, but I could conceivably think of it as radical 1, right? 4 radical, you would never write that because why would you write radical 1, which is 1, and 4 times 1 is 4. So it's not there, but I could think of it like that, right? So now what would it be? Perfect. So you can think of that radical 1 there, but 8 root 7s times 4 is 32 root 7s. Okay, just a conceptually different way of thinking about it. And 7 can't break down. Okay, number 4, what first task comes to mind here, Jack, when you look at something like this? Jack Birmingham. You're thinking of the right thing, you're saying the wrong thing. Not factor it. It already is factored out. We want to, it starts with a D. Distribute it through. Very good. So Jack, keep going here. What would 8 root 3 times 5 root 6 be? Perfect. And the next distribution, what would that look like, Kate? Perfect. Now, simplify. Can I break down 18 at all, Natalie? Yep, root 9, root 2. So what would that become overall? Very good. And how about the 16 root 9? Take me through that, Jason. Right. That's just 3. So no breaking it down. You can just flat out simplify it. 16 times 3 is 48. Okay. And from here, what do you think? Corey? Very good. He didn't fall for my trick question. Do not add the 120 and the 48. That's 120 root 2 plus 48 root 1, technically. And those are not like radicals. This way of it being written is a little less misleading. Sometimes I see kids when it looks like this. This is when people will add these, and that's a big no-no. Okay, they'll add those because it's just so tempting, but you cannot do that, okay? Great. Number 5, when I multiply these, Chris Brooks, what do I get? Perfect. X times x cubed is x to the 4th. Great. Root 18 is root 9 root 2. What should I do with the root x to the 4th? Can I break that down at all? What do you think, Haley? It's not going to break down to root x squared. It's actually going to stay root x to the 4th, and then when you take the square root of it, it will become x squared. Does that make sense? Because it's an even exponent, we want to keep it even. We don't need to break it down into anything. But then when we actually apply our square roots, we've got a 3 x squared root 2. And 6. Bella, what do you think this will be initially?
16. I don't know.
Are you getting 16 from multiplying the 8 times the 2?
Oh, would it be 2 radical?
Yes. Not radical, 4th root of.
Yeah.
We have to be a little more specific if it's not the square root.
So 2 4th root of 48.
48 what?
X to the 6.
Perfect. So she initially multiplied the 8 times the 2. Hopefully we all can see why that's a big no-no, right? 8's under the radical, 2 is not. So here's where we are first. Now, how can we break down 48? What perfect 4th root goes into 48? Mike? This probably would take you a few seconds to figure out because we don't know our fourth powers very well. You kind of have to go remind yourself what those are. And by remind yourself what those are, I mean multiply something by itself 4 times. So 81, that's a fourth power, but obviously we're not breaking down 48 into 81. Yes, 16 times. So the 4th root of 16, 4th root of 3. Thoughts on x to the 6th? Lucas B. Do we break down x to the 6th? Are we happy with the way it is? And why are you saying leave it? Because 6 is... Well, I can break it down. I could break it down to x to the 5th times x. I could break it down into x to the 4th times x squared. So why don't you want to break it down? Someone help him out. Other Lucas.
It's even.
So because it's even, you don't want to break it down. Thoughts on that? That's true if it's the square root. We're not taking the square root though, guys. We're taking the 4th root. So we need that exponent to be a multiple of 4. If it's a square root, we need it to be a multiple of 2, hence why we keep looking for evens. If it's a 3rd root, we need it to be a multiple of 3, which actually this one would have been. 4th root, you need it to be a multiple of 4, and 6 is not. So we do want to break down x to the 6th into x to the 4th x squared. Does that make sense? So I've got the 2 there. The 4th root of 16 is another 2. So 2 times 2 is 4. That covers those 2. And then the 4th root of x to the 4th is just x. And then these 2 are stuck under the radical. So 4th root of 3x squared. I love this next one. Here's what it becomes. What was it prior to having any coefficient out in front? So let's first focus on the number. In the final answer, there's a 5 underneath the radical stuck there still, and there's a whole number 2 that came out in front. The cubed root of what would have pulled a 2 out in front for me? Lucas? 8. Very good. So this probably was 8 times 5. The cubed root of 8, which became the 2, and the 5 that's still there. So that would be a 40. So that covers that. An m got brought out in front. The cubed root of what would have pulled an m out in front? M cubed. So there must have been an m cubed under there times this m that's still there, which would have been an m to the 4th. Very nice. An n squared got brought out in front. Olivia, what would you need to take the cubed root of that would have become an n squared? Not quite. The cubed root of n to the what would have become an n squared. Essentially, 3 has to go into whatever this is twice. 6. So n to the 6th would have had a cubed root of n squared. And there's also an n squared that's still trapped under there. So that would have been n to the 8th. And there we're done. So that's just like an interesting twist to make you think of it differently. Okay? Flip to the back for me. All right. This one's an interesting twist as well. Totally Common Core-like. You know, that's never straightforward with them. They make sure you understand this inside and out. And truthfully, problems like this help you do that. When you're simplifying the nth root of 3, can we break down 3 at all? No matter what root we're taking, we can. So I'm going to keep that the nth root of 3. And then it's going to be the nth root of 2 to the n. What will that be? 2, right? If it was the square root of 2 squared, or the cubed root of 2 cubed, or the fourth root of 2 to the fourth, wouldn't that always just be 2? So that one will be a 2. So I'm going to circle that. We'll get there. I can do that just to kind of track. The cubed root, oh, not cubed, nth root, sorry, of x to the 2n. Remember, we're looking for how many times does n go into 2n, right? How many times? Twice. So I will be able to make this keep the same base of x to the second power. For example, if n was 3, it would be the cubed root of x to the 6th. That's x squared. If n was 4, it would be the fourth root of x to the 8th. That would be x squared. Good? And on your nth root of y to the n plus 3. Remember that if we can take the nth root of this, n needs to go into the exponent evenly. Does n go into n plus 3 evenly? Not really. Unless you knew n was 3, then that would work, but any other number that wouldn't work. And furthermore, we don't know what n is. So what we can do, though, is we can break down y to the n plus 3 into y to the n times y to the third, can't we? And we can take the nth root of that. Because the nth root of y to the n is just what? Y. And then the nth root of y to the third I can't really touch. So here's what I have out in front. I have a 2. I have an x squared. I have a y. And then under the radical still, I have the nth root of 3y cubed. Definitely takes a deeper level of understanding to get that. The next two aren't really multiplication at all. I just know how breaking down radicals can be tricky for you guys, so I just gave you another opportunity to do adding and subtracting, which requires you to break things down first. But I did it with higher roots. So, first of all, the 6th root of 3, good. I don't have to do anything with that because I know I can't break down 3. But 48, what perfect fourth powers go into 48? I'll check for fourth powers because I don't know them off the top of my head. 2 times 2 times 2 times 2 will give me a perfect fourth power. Does 16 go into 48? Yeah, so I would break that down in 2 times the fourth root of 16, fourth root of 3. And the fourth root of 16 is 2 times that 2 makes you have a 4 fourth root of 3. Here's 4 sixth root of 3 minus 6th roots. Dear Lord. 2 times 2 times 2 times 2 times 2 times 2. So there's a perfect 6th power. Does 64 go into 192? How many times? 192 divided by 64? 3. Awesome. So I'm going to make that 3 times the 6th root of 64 times the 6th root of 3. So the 6th root of 64 is a 2. Times that 3 is going to make minus 6, 6th root of 3. And, oh, that was silly. I should have just combined these two right from the start because they were both the 6th root of 192. Oh, well. Minus 2, and then we do the same thing. 6th root of 64, 6th root of 3. That's minus 2 times 2, which is minus 4, 6th root of 3. So I can combine term 1, term 3, and term 4. 4 minus 6 is negative 2. Negative 2 minus 4 is negative 6 of these 6th roots of 3, plus 4 of these 4th root of 3. remember, this really highlights the fact that these are not combinable. They're both radical 3s, but one's a 6th root and one's a 4th root, and you cannot do that. Good? Any questions?